Okay guys, so welcome back. In this lecture we are going to do the last 10 MCQs of this paper from 31 to 40, right? May June 2010, variant paper 1 variant 2 and physics 9702, right? So let's get started. All right, so MCQ number 31. Okay, in terms of energy transfer and charge, what is the definitions of potential difference and electromotive force? Okay guys, potential difference is when the electrical energy gets converted into other forms of energy, whereas EMF is when other forms of energy are converted into electrical energy. So this is actually the work done per unit positive charge to move it around the circuit, and this is the work done per by a charge as it moves across the circuit. Okay, so this is also work done per unit charge, and this is also work done per unit charge. So both of them are will have the same formula. Answer option A is correct. Work done by the charge and work done on the charge. That's the only difference in between the two formulas. Moving on to the next MCQ. All right, we have combination of resistance in resistors in here. The ammeter has a resistance of 2 amperes as well, or 2 ohms as well. All right, so just assume that this is also a 2 ohm resistor attached. Now, which arrangement gives the largest reading on the ammeter when the same potential difference is applied between the points P and Q? All right, guys. Now, one thing to remember over here is that if the lower the resistance, the higher the current. All right, this is the rule because we know from Ohm's law that V is equals to IR. If voltage is constant, as they told us in the question that the same potential difference is applied. So if potential difference is constant, then current and resistance are both inversely related. Now let's see the circuit that has the least resistance in there. All right, so if we calculate the resistances over here, so these are series, just add them up to get the total resistance. It's 5 ohm over here. What about this? All right, so two of them are in parallel, one is in series. Okay, so let's calculate it quickly. All right, so to calculate the total resistance of these two, it's going to be 1 into 2 upon 1 plus 2, product upon sum for two parallel resistors, and it turns out to be 2 upon 3. Now this 2 upon 3 is in series with the ammeter, so add it up with 2, and you'll get 3 and 2 plus 6, which is 8 upon 3 and 2.67. All right, 2.67 ohms. Okay, it has lesser resistance as compared to this first one. What about option C? Okay, 1 plus 2 is actually 3. Okay, these two are 3 and 2 are in parallel. All right, so 3 times 2 upon 3 plus 2, and it turns out to be 6 upon 5, which is 1.2 ohms, even lesser. And what about the last one? All right, all three are in parallel. All right, so we'll need to use the complete formula. 1 upon RT equals 1 upon R1 plus 1 upon R2 plus 1 upon R3. All right, so let's add them up. This becomes 1, and 1 plus 1, which is equals to 2. 1 upon RT equals 2. Just a moment, guys. Okay, 1 upon RT equals 2 in this case. And if 1 upon RT equals 2, then RT equals 1 upon 2, which is 0.5 ohms. And so option D is correct. It has the least resistance. Option D has the least resistance. All right, it has 0.5 is the resistance in here, and it's the least resistance. All right, now let's move on to the next MCQ, number 33. All right, it says that the source EMF has 9 millivolts and the internal resistance is 6 ohms. It is connected across a galvanometer of this much resistance. What is the current in the galvanometer? So in other terms, they are just asking us the current, and all the different resistance values are given and the EMF is given. All right, for such questions, it is always easy to draw a circuit diagram first. All right, we have our internal resistance as 6 ohms. We have a 9 millivolt battery over here, and we even have a galvanometer. I'm not drawing a galvanometer. Instead, I'm just giving a symbol of the resistor of 30 ohms, right, because it has resistance of 30 ohms. And now they are just simply asking us the current in here. The total resistance is 36. We have the total resistance, we have the total voltage 9 millivolts. Can we calculate the current? Yes, we can, using the Ohm's law. I is equal to V upon R. The milli must be converted into ampere, into voltage first, and then later on we'll convert it for our answer. The answer that we get to this part is 0.25 raised to the power of minus 3 and ampere. Now let's see which one of them matches this answer. All right, it's actually 250 micrometers, because if we convert it into 250, it becomes 250 raised to the power minus 6 amperes, and so answer option A is correct. Now let's move on to the next MCQ 34. All right, in here, P, Q, and R are arranged in the circuit with equal resistances. P, Q, R all have equal resistances. The battery of negligible internal resistance supplies a power of 12 watts. All right, this is the power that is supplied. What is the power dissipated by heating in resistor R? Okay, what is the power in resistor R? That's what we need to calculate. All right, guys, it's pretty simple though. We know that each of them is have an identical resistance, so let's assume that all of them have a resistance of R, R, and R. Now let's calculate the total resistance first. All right, and while doing so, what we could surely do is that we could calculate, instead of writing two r's, first let's assume that let's take the collective resistance of the two. They are in parallel, so the collective resistance will become r upon 2, right? R upon 2 is the total resistance of q and r upon 2 and r are in series with one another, right? They are both in series with one another. If we assume that we've replaced these two resistors by one resistor having a resistance of r upon 2, and this one is just r, so now they are in series with one another. Okay, what is the law that applies in series? Power is equals to I squared r. We know that in series the current is constant, so power will be proportional to the resistance. All right, if power is proportional to resistance, then we can easily calculate what's the power across this p. All right, so what's the power across this p that is lost across this p? All right, so we can do that, and then in doing so we can also calculate the power lost across q and r. All right, so now if the power is proportional to the resistance, then we know that the power will also be dissipated across P and across Q and R combined in the same ratio as their resistances. Okay, since the resistance of P is R and since the resistance of Q and R combined is R upon 2, then the power will dissipate double. Okay, the power loss across P is going to be double the power loss across Q and R, because the resistance of P alone is double the resistance of Q and R collectively. All right, so this would mean that 2/3 of the power will be lost across P, which makes it a total of 3 4s are 3 times 4 into 4, 2 times 4 is 8. 8 watts will be lost across P, and the remaining 4 watts will be divided between Q and R. Now, since we know that Q and R are both identical, then the 4 volts will also be the 4 watts, I should rather say, will be divided, split it in between the two resistors in parallel, and it will become 2 watts across Q and 2 watts across R. Right, so 2 watts is the power dissipated across R. Right, this is the best answer. Now let's move on to the next MCQ. In deriving a formula for the combined resistance of three different resistors in series, Kirchhoff's laws are used. All right. So we are actually calculating deriving the formula for combined resistance of three different resistors. All right. So now what we need to do over here is that we let's go over the MCQ options one by one. All right. It says that the first one says that conservation of charge. Okay, principle involved in this derivation. All right. We are considering those in series, right? So, okay, in series, what happens? Yeah, okay, conservation of charge is involved. Yes, then direction of the flow of current from negative to positive charge. Current flows from positive to negative charge, guys. Flow of charge from negative to positive can be in both the directions, right? If electron is flowing, then from negative to positive, and well, it doesn't have anything to do with the derivation though. The potential difference across each resistor is the same, but in series, no, it's not the same. It divides between them. The current varies in each resistor in proportion to the resistor value. No, it varies inversely with the resistor's resistance. All right, D cannot be the answer, C cannot be the answer, and B can also not be the answer. A is the correct answer, and yes, law of conservation of charge is used over there. Kirchhoff's first law is used in that derivation, and right, let's move on forward. What about MCQ number 36? What is the unit of resistivity? All right, for this MCQ, for this MCQ, all you need to do know is the basic formula of resistance. Resistance is equals to rho L upon A, where rho represents the resistivity. All right, just rearrange it and form rho the subject, and it becomes RA upon L, and R's unit is ohm, area's unit is meter squared, and length's unit is meter. So meter squared get cancelled out, and ohm meter is the correct answer. Moving on to the next option, 37. The grid shows a number of nuclides arranged according to the number of protons and the number of neutrons in each. Alright, a nucleus of the nuclide is this. It decays by emitting a beta particle. Okay, if it's just mentioned a beta particle, we assume that they are talking about beta negative particle. What is the resulting nuclide? Alright, now we have a grid shows the number of nuclides arranged according to the number of protons and the number of neutrons in each. The nucleus of nuclide lithium. Alright, now we have lithium, and its nucleon number is 8, its proton number is 3. Alright, it decays by emitting a beta particle. Alright, so if it decays and emits a beta particle which has 0 nucleon number but -1 as the charge number, then the resultant that we get, let's assume that the resultant has the symbol X. Alright, this resultant will not have any change in its nucleon number. And what about its proton number? The proton number will increase by 1 unit. Alright, so what is the resultant nuclide? Okay, 8 and 4, and this is the nuclide that we should get. Alright, so what option could be correct? The number of protons. Okay, it must have 4 protons. Yes, it can be either A or B. Okay, what is the number of neutrons in there? Okay, 8 minus 4 is also 4. So 4 neutrons are there. So 4 neutrons and 4 protons. So answer option A is correct. Okay, they both overlap over here at A. Right, so answer option A is correct for 37 as well. Now let's move on to the next MCQ. Third last MCQ. Okay, the last 3 MCQs over here. All right, now the following represents a sequence of radioactive decays, all right, involving 2 alpha particles and 1 beta particles. All right, alpha particle, as you guys, I should remind you that alpha particle is actually the nucleus of helium atom, all right, which has a charge of +2, and this is the nucleon number, this is the proton number. All right, now 2 alpha particles are removed, 1 beta particle is removed. What is the nuclide X? Okay, what is the nuclide that you get? Now if this astatine that from where you started off, 217 and 85, from here if we get this X, and we got how many? 2 alpha particles, helium 4 and twice, and 1 beta particle. So let's calculate the resultant. All right, now 2 times 4 is 8. All right, 8. This means this 217 will decrease by 8. Okay, decrease by 8 would mean it becomes 209, right? And what about the other thing? Right, now the other thing, it okay, due to this -1 it will become 86, and then from 86 we'll have to remove 4 protons as well because of this 2 alpha particles, so it will become 82. So it's actually lead. Okay, 209 and 82 is lead. All right, now option C basically for 38. Now let's move on to 39. What are the correct description for gamma ray and beta particle? Gamma rays, as you know, are high frequency electromagnetic radiations. Beta particles are high velocity electrons, negatively charged electrons. Rays, okay, gamma rays are electromagnetic radiation. Beta particles are high speed electrons. Option C is correct again. Okay, what is not conserved in the nuclear process? Okay, basically guys, the total number of nucleons. Total number of nucleons means the sum of all the nucleons. Sum of all the nucleons is conserved. Okay, so D cannot be the answer. Momentum is always conserved. Again, cannot be the answer. Charge is also always conserved, so cannot be the answer. Total number of neutrons. Okay, guys, neutrons can vary, right? Because it's in beta decay, it's a neutrons that do decay into protons and electrons, right? So yeah, neutron number can change. All right, so it's not conserved. Okay, so answer option C is the correct one for 40. Thank you so much, guys. This completes this paper. We'll be giving more lectures soon enough. Okay, guys. So thank you so much.